Alright, so a little bit of a different video today. I normally do crypto content, but I kind of just want to test the waters and try out some programming. So I'm going to kind of talk about encapsulation and linear linked lists today. So basically we have a list.h file, which is a header file, and we have our includes here, IOStream. We don't have to worry about this one. This is irrelevant for this. Fstream for files and whatnot. Actually, I'll keep that in there. Never mind, it's an issue. Okay. Anyway, so linear linked list right here. We have it defined here as a struct node. Computer is our data type. I have it in a computer.h file as a class. And then it's data, so we have a pointer to data. And then we're using node with a pointer to next because that's how linked lists work. And then we have a class list. And then we're going to have a default constructor here, which is list, our deconstructor, and then our functions have a print menu, add computer, print computers, delete computer, write computer, and read computer. And by computer, I mean the program altogether. This big program I have is it's a network manager. So it's just a small little network manager. It was a little assessment that I had, and basically this prints the menu of functions we have. This is a function here. We have add computers. You can add a new computer to the network. We can print out all the computers in the network. We can delete a certain computer on the network. We can write the computers to a file, and we can read them from a file. So that's essentially what our functions do. And this is in our public data. So our private data, we have a node head, which points to the first node in the list, the linear linked list up here. We have node tail, which points to the last node in the list. And then we have other functions for getting integers and strings. We have add to list, which, well, we don't have to discuss that one, but get integer, which is for getting integers, and get string for getting strings. And the reason why we do it like this is because we want to avoid buffer overflow, so we have exceptions and all that. So yeah, so let's get into our list.cpp file. So first, right here, we have include list.h, so we're including the class definition, and we're encapsulating the data. So we have these functions here, but we're gonna write them in here. So this is called encapsulation, where you kind of hide the background information. I guess I don't really know how to pronounce. Sorry, not pronounce. I don't really know how to say this, but basically you write your functions here and then you write the code for your functions in a different C++ file. And that's essentially what encapsulation is at a basic level. With my understanding, it is. So anyways, we have the list constructor here, which is also right here. So we're setting the head and the tail to null and then count to 0. And then we have a deconstructor here, so that's here. And since we included it from list.h, we can access it in here. So we have deconstructor, which we're going to traverse the list. And then while the head is not null, we're going to do a current. We're going to delete every element from the list until everything is done, until the head is null. Yeah, so then we have our print menu function, which essentially prints out the menu in the console. So add, list, read, write, delete, help, which will show this help menu, quit, which ends the program. We have add computer, which has a host name. Here's the things we need for a computer: a host name, owner name, an operating system, IP address, and a location. So location as in like, I don't know, library or room 2, room 1. Response, which is what we respond to with this while loop. So while count is less than 100, we're going to do cn.clear, and then we're going to hit the computer name, and then we're going to get string, which uses cn, and it just makes sure that there's no buffer overflow that can occur. It limits it. Yeah, we do the username, OS, IP address, and then the location, and then we create the computer using a new object. So, and a new computer object in our computer.h file, and then we add it to the list, which is another function that we have, which doesn't matter. This is fine. We don't need to worry about this right now. Then it asks if you want another computer, yes or no. You get the response. And if response is equal to no, then you break. If not, it keeps going, and then we iterate. Sorry, not iterate. We add one to the count. Print all computers in the computer list. So essentially, now we're on print computers. This will print out everything in the linear linked list. So we say listing out all devices. If if head is null, we no computers entered, and then we return from there. And then if not, then all computers. We traverse the list, and then we print out each computer for in the list. So yeah, all right, now let's go into our next function. So void is a void function, list delete computer, so that's also here. This will delete a computer, and you have to delete it by username. So if it's null, then return, enter username to delete, you enter in a username from the list. And then yeah, so node current head, previous null, we iterate through it, and we get the owner name, and we try to figure out which username matches the one that we have. And then yeah, so if it doesn't work, then we hit say unable to find field with this username. And yeah, if you guys want more information about all of this, then I'll leave a link in the description on how to create a linear linked list and how to iterate through one and understanding absolutely everything. Because I'm not gonna explain all of this. This is pretty basic stuff, but yeah. Anyway, so now let's go to our write computer file or write computer function. So these are the functions are gonna be ones that require f string or what's it called? Yeah, f streams. So we have write computer and read computer. And within a write computer right here, we're gonna use os stream out file, which is an output file. If there's a problem creating an out file, we say that, we return. If not, we enter a file name, we iterate through everything, we put it into the file. And then we say file creation successful, then we close the file. And then let's see, read computer, this reads from a file, so we take all of our variables, get the in file, we enter it in, if there's a problem creating it, it's kind of similar to the other one, and then we get the line of each file and then match it up, and then we create it as a new computer object here, and then we close it after that. And other functions, that's add to list. This is just adding the computer to a linear linked list. That's also pretty basic. Yeah, and then we have Git Integer, which I don't think this is used, but I have it in here. It just gets an integer and makes sure that it's not like a legal character or string or a char. And we have get string, which it's C strings. I'm using C strings. I'm not using the actual string, which is better. I just prefer for my assessment I have to use C strings. But yeah, cn.get, we did all this here. And then while not cn.clear, ignore. If there's an issue, you didn't enter anything, please enter again. It keeps going. So yeah, that's encapsulation in a nutshell. I mean, it's pretty much just hiding these functions, not having all of it just out in one file. I guess it's kind of organization. That's the way it was taught to me, kind of being organized. So yeah, this is something new. So I'm not gonna start making content like this. It's just something to clear my head of crypto and just kind of try out something new. So yeah. All right, guys. Hey, take care.